Hello, our next speaker is Bill Gillette, who is the president at LogiLube, and he will be discussing edge computing, autonomous live sampling, real-time fluid condition monitoring, data analytics, and wireless connectivity for mining equipment. And you can find out more about him and connect in the speaker profiles. Make sure I'm playing the right one.
My name is Bill Gillette, and I am the CEO and founder of LogiLube LLC, a technology company based in Denver, Colorado. Today, I'd like to present the new SmartOil-M technology that was developed for the mining industry. The actual functions of the system are many actually, but as you can see, it is a hardware and software system. It actually facilitates a fully autonomous live fluid sampling from mining equipment such as haul trucks, excavators, or even stationary equipment like mills. Given the fact that it is an autonomous system, it also removes people from harm's way of actually collecting oil samples from equipment that's actually operating. Furthermore, you can see on this slide that we also have the ability to incorporate multiple external sensors. The sensors listed are currently supported, and they include viscosity sensors, particle counters to derive the ISO cleanliness code, particle detectors, both ferrous and non-ferrous, as well as water contamination in oil. The system is actually powered by an embedded computer or an edge computer that's inside this unit, and that actually helps facilitate not only the limits when they've been exceeded, but also to manage the bottle fill events. In addition to autonomous oil sampling, the SmartOil-M system also has the ability to capture data and send it up to the cloud or to the client's network. This is done through a Bluetooth connection. It's actually a long-range Bluetooth connection, up to 1,000-foot line of sight, and it actually sends the data as well as the event history from sampling. That data actually gets sent to through a companion app, a mobile app that's running on an internet-connected device, a smart device like an iPad or an iPhone. The value proposition of this M series is rather straightforward, and there's 4 top value propositions: improved safety, accurate sampling, increased equipment uptime, and of course, dollar savings in lower operating costs as well as increased revenue. The SmartOil-M device is a hardware solution as well as a software solution combined with an internet-based data management system. As you can see in the slide, the hardware actually communicates through the web via an internet-connected device, a smart device like an iPad or an iPhone, through a companion app, a mobile app, and that allows the user to actually query the devices and check on the status of the various fluids, as well as to remotely trigger a fluid sample from the safety of not being on or near the equipment. Additionally, the mobile app allows communication to the devices for updating firmware, updating software in the background through an over-the-air process. And lastly, you can see there's an arrow that starts from the M device through to the mobile app, providing real-time condition data for each of the fluid streams. The next slide actually illustrates a summary of the hardware features, not only the connectivity, the various data feeds and methods, power, as well as the various agency approvals that this device has gained in the recent several months actually. The system is approximately 5.5 inches in diameter, about 12 inches tall, and weighs about 8 pounds or so. It is mounted directly to a piece of equipment, be it a haul truck engine or possibly plumbed into a transmission, steering, final drive, etc. You can see in the image in the lower right the fluid path as the oil or working fluid passes through the system through some sort of a bypass loop or a kidney loop for about 1.5 gallons per minute flow rate. Next, I'd like to introduce you to the mobile app. And as you can see on this slide, the user would actually access the mobile app through, in this case, an iPad. And after signing in, the client gets to query all kinds of data and impart some controls to the M unit. This next series of slides actually walks through an example of how a mechanic or a technician could investigate a potential problem with a large piece of mining equipment. In this case, it's a large haul truck. You can see on this slide where the engine oil is being monitored with one of the M units, and there's some sort of a warning or alert that was picked up by the IoT sensor, processed by the M unit in real time, and then linked via Bluetooth back to the cab to some sort of a bridge, in this case a Bluetooth to a cellular bridge up to the client's network. It could also go straight to the cloud via a cellular connection. This next slide is actually a screenshot of what the mechanic or technician might see as he or she navigates through the various filters to actually find the asset. You can see highlighted with the orange buttons, mobile versus stationary, and nearby assets versus all assets. The highlighted asset circled in red is actually the asset in question. As you can see in this slide, the haul truck is actually entering the bay of the shop. The mechanic standing in a safe zone away from the haul truck is actually directing the driver to halt for just a minute outside of the garage, while the mechanic actually queries in this case 6 different fluids to determine the health of the fluids, for the most part looking to see if there are any warnings or alarms, or even if the various sample bottles have been filled or need to be filled. As the mechanic transitions through the slides, this particular asset is further down selected. You can see from the screen there are 3 mobile assets that are within Bluetooth range, and again the item circled in red is a particular haul truck of question. And furthermore, the mechanic has actually now pulled up data on the actual 6 different fluids on this haul truck. The menu on the left actually gives the mechanic a view of all the various fluids and some basic conditions for each of them. You can see in this example that there is multiple fluids being actually monitored in real time. Each fluid has its own dedicated M unit. In this example, engine oil, hydraulic oil, final drive oil, transmission oil, steering fluid, and coolant. This slide illustrates what the mechanic might see when actually querying the engine fluid, the engine oil itself. And you can see the big bold number of 313. That's the number of hours remaining between now and the next auto-generated sample. The additional text below 313 is actually a collection of additional data that the mechanic might find useful, and that would be the sample period, whether it's based on a calendar or if it's based on machine time, the operating machine time of the engine. It also estimates the the next automatic or automated sample that would be generated if this system was operating out in the field. And then also you can see the status of the bottle. In this case, the icon is empty, so therefore the sample bottle is not full. And you can see from the orange button, the mechanic can actually initiate remotely a manual sample process. Moving along, this slide really summarizes the mechanic's view and some basic information that the M series can provide for this particular installation. In general, we're talking about multiple fluids, real-time condition monitoring of the fluids, live fluid sampling capabilities, a remote sample triggering from a wireless tablet, and also safety, safety, safety. Safety comes first. This entire technology solution provides for live sampling while preventing the people or the technicians from actually being in harm's way, and it also eliminates live work, which is a new initiative amongst the top global mining companies. To further delve into some of the slides that the mechanic might have access to from the mobile app, you can see here in this slide, the engine is actually highlighted. It's circled in red on the left menu on the in the orange column. And to the right are a series of data panes, as we call them. I've actually circled the temperature in red, but below that you could query water temperature, actually it's water contamination, water in oil contamination, as well as the oil pressure, and further below, if you were to scroll down, you might see viscosity, oil cleanliness, particle count, etc. Furthermore, looking at the data pane for oil temperature, I've circled two key attributes, and that is warning and danger level. Those are actually limits or thresholds of settings that were determined by the client during the commissioning process of this particular M unit for the engine oil. And you can see in gray the specific values in Fahrenheit, and those are the preset temperatures. And if this oil temperature, which is 178.4, was to exceed either the warning or the danger, there would be a change in the color of the data, as well as the system could automatically send a text alert, an email alert to a registered list of recipients that would need this data. This particular slide illustrates several key icons that are quite important for a reliability engineer and or ops folks. And that is the ability to view data, historical plotted data. And as you can see circled in red, there are a few icons scattered throughout this screen of a tiny little graph. And if you were to click on either one of those, it would take you to a slide that actually graphs or plots the data for the particular sensor. Now, each of the data panes that has a data subscription, that the client's engaged in a subscription for the data, that data pane actually has that icon, and then when it's clicked, you can actually plot the particular history. In this case of this slide, there are two graphs that are plotted, and one is for temperature and one is for pressure. The system has the ability to plot 4 simultaneous data feeds over the top of each other. And like most smart tablets using the pinch and zoom process with your fingers, you can change the scale of the data plot, either broadening it out to look at it from a weekly, monthly, annual view, or really zoom in this case, on an hourly basis. And pinch and zooming the other direction, you can change the y-axis as well. This particular slide actually walks you through an example of what happens when you want to take a manual sample. So there is a, on the engine selection in the upper left of the orange menu, you can see the bottle icon is basically outlined. It's not filled with a color. It's not black. It's not red. And furthermore, in the data pane, you can also verify that the sample status is an empty bottle. So again, from the safety of a remote safe zone, the mechanic or technician can actually initiate or trigger an automated autonomous sample remotely. And by pressing the orange button labeled Take Manual Sample, boom, it initiates it basically communicates via Bluetooth back to the device that's mounted on the haul truck, and actually processes the sample. Now, a key thing to note is the sample bottle might be 90 milliliters, 100 milliliters, even some custom range. That can all be programmed during the commissioning process, as well as during the commissioning, the viscosity of the fluid. If it's a gear oil, it might be quite high. If it's a transmission or hydraulic fluid, it might be maybe an ISO 32. So the length of the time that the valve is remained open to fill the bottle is determined. It's calculated. Again, we have an edge processor, so it can take into account temperature, pressure, viscosity to instantaneously calculate the length of time the valve stays open to properly fill the bottle. So a couple examples. This is a classic 125 milliliter standard bottle. But if I was to have a smaller bottle volume, I would want to program that into the device during the commissioning process so the bottle is not overfilled and makes a big mess. This slide actually summarizes that manual bottle sampling process. Again, you can see the mechanics view, a zoomed in view of the actual orange button to actually take the sample. It sends a Bluetooth signal out to the device. The particular M unit that's affiliated with the oil sampling then basically executes that sample and fills the bottle. Upon the completion of this sampling, there is a notification back to the mechanic, again via Bluetooth to the device then to possibly the client's network, that the bottle is ready to be harvested. When the sample process has been completed, again the mobile app screen actually gives an indication that the sample has been processed. It gives a status of the sample bottle, and it would have a big bold, completed, ready. Come get the bottle, harvest it, send it back to the third-party laboratory. I'd like to actually introduce you to the actual M units and some of the technology around it. I have over here on my left, I have two different units. One, as you can see, is labeled for hydraulic fluid, and the other is labeled for engine oil. And there could actually be 3, 4, 5, 6 of these, depending on the different fluids that are being monitored. Right off the bat, you're going to see a QR code. You're going to wonder, well, what's this all about? Well, when the sample bottle is being harvested, the mobile app using the iPad or iPhone device running the mobile app actually can scan this QR code, which actually embedded in it has a particular asset location, the fluid type, the fluid information. It could be a Shell, an Exxon, a Total fluid, and that's all embedded in this code. And then the sample bottle would also have a barcode. So the mobile app walks through the scanning process of first scanning the sample point information, second scanning the barcode on the lab provided bottle, and when the mechanic's done swapping out a used bottle for a new bottle, and that's actually underneath this aluminum protector, then the mobile app actually prompts the mechanic to actually hit the submit button. That data then goes off to the cloud or to the client's network to actually log the fact that there is a new sample that's been collected and it's ready to go to a third-party lab. Additionally, let me tip this forward a bit, and you can see the actual top of this unit. And you can see here a series of buttons and LEDs. And I'll give you a better view of that. I have a sample right here. And you can see there's a big fat reset button. And underneath this, this panel is a snap dome. You can hear it, and it's a very tactile system. And so what happens is when the bottle's been collected, the mechanic would press, the last step would press this reset button, and it actually tells the system that a fresh new bottle is in place. And so when an autonomous scheduled oil sample comes up for filling a bottle, it doesn't put new oil on top of oil that's already existing in a bottle. I mentioned also there's an edge processor. So on the inside of underneath this cover is a 5-layer PC board assembly, and you can see a whole array of these black connectors. Now, what are those for? Those are for the possibility of adding optional sensors through these various sensor connector ports, and I have several examples here. This is a viscosity sensor, which measures not only viscosity, but the fluid's density and temperature and dielectric constant. Also, sensors for measuring water and oil contamination. And there's a myriad of other sensors as well. LogiLube is not a sensor company. We are completely agnostic to sensors, but there are many best-in-class IoT sensors that could be utilized by this smart oil system. Back to this printed circuit board and the embedded computer, these various black connectors are actually a series of, whether it's Modbus 485, it could be RS-232, it could be just a 4 to 20 milliamp, a CAN bus J1939 spec. We really don't know what the client or the application might require, but by having them all pre-designed and pre-programmed and connected so that whatever data comes in can be processed by this edge processor. We also have a 3-year lithium-ion battery for battery backup, and there's a big 4-core ARM processor to drive all this. So once again, in summary, it's a very robust machined aluminum and clear anodized system. It's solid billet machined. The actual bottle unscrews, and if the sample bottle utilizes a different thread design than this 38 by 400 neck finish, this bottle mount, this black part on the bottom, can be reconfigured to a different custom thread design. So there you have it, the LogiLube SmartOil-M Series.
Hello. So this is the Q&A portion. If anybody has any questions, feel free to ask them now. If not, we can go ahead and start with, what are some frequently asked questions you get from other people that you've encountered?
Okay, any questions?
Not seeing any.
One of the questions that we received often is, what is the range of different fluids that can be monitored with this system? And as indicated, really it's a wide variety of viscosities. Since it is a kidney loop, we could receive coolants or gear oils. So it really doesn't matter viscosity-wise.
What do you see happening in the future with a continuation of this technology?
I see a greater demand for integration of a wider variety of different third-party sensors, be it a spectrophotometer at the far end, down to viscosity and water contamination and so on. So that the range of sensors could be very demanding, from power, data communication, edge processing, to very simple, go, no-go sort of gauges.
We have a question. Is it only for hydraulic and engine be used? Is it tested in turbines?
Yes, we've been actually tested in turbines as well. So again, any hydrocarbon fluid would be this is suited for, as well as coolants.
Someone said, "Hi Bill, you mentioned SmartOil-M is for mining, but is it able to be used in other applications and assets?"
Absolutely. We actually have used our technology in the oil and gas space, specifically in natural gas compression, in refineries for turbines providing primary power, wind turbines as well. These large gearboxes that have heavier oils and so on. But this presentation was really focused on mining because we've been engaged in a series of some extensive pilots throughout Australia and Chile in the mining industry.
Does anyone have any more questions? If not, is there any information you would want to leave people with before we end?
Yes, we actually are excited to participate in this transition of live sampling within these very dangerous industries, basically removing human beings and mechanics and technicians from the entire process of oil sampling and monitoring with our remote technology, where you can actually access and control this technology through a wireless device 50, 80, 100 meters away.
Someone said, maintenance and self-diagnosis of product.
We actually have built into the edge processor the ability to update the firmware and software remotely using what's called an over-the-air update process. And in our next generation of printed circuit board and edge processor, we're adding a lot of self-diagnostics within the circuit as well, so they can report on low power situations or dirty power, or even excessive vibration or high temperatures. So there'll be a self-diagnostic capability as we roll out into the next generation.
Awesome. That is about all we have time for. I appreciate it. I thought it was interesting, and you did a good job presenting. And at the end, everybody. Bye.
Very good. Thanks all.